Good morning all. In today's class we'll learn study of algorithm and the analysis of the algorithm. A sequence of steps have to be performed in designing and analysis of the algorithm as shown in this diagram. The first is understanding the problem, model development based on computational capability, algorithm design, proving the correctness of the algorithm, analyzing the algorithm, implementing the algorithm, and program testing. These are the steps which have to be followed while designing the algorithm. Now we will take up each and every step one by one and understand it. First is understanding the problem. When a problem is stated, we have to understand precisely what is the problem to be solved, what is the input and what is the output. It is also very essential to specify the exact range of inputs given to the algorithm. If exact range is not specified, the algorithm may not work correctly for a majority of inputs and crash on some other input. We should note that correct algorithm is not the one that works most of the time, but that one that works correctly for all legitimate values. Next is the model development. After stating the problem clearly, mathematical model should be constructed. The problem can be represented using a graph or a network or any suitable mathematical model. A mathematical model can be built for any specified problem. Apart from these, various activities are involved. Those activities are ascertaining the capabilities of a computational device, choose exact or appropriate problem solving technique, selection of appropriate data structure. First we'll take up ascertaining the capabilities of the computational device. Once we understand the problem clearly, we need to ascertain the capabilities of the device. This is because the computers we use mostly are von Neumann architecture based, that is stored program concept. In these machines, the instructions are executed sequentially, that is, they are executed one after the another. So we have to design the algorithm in such a way that these algorithms should execute on these machines. Algorithms that are designed to be executed on von Neumann architecture are called as sequential algorithms. And there are algorithms that are designed to be executed on parallel computers that take advantage of parallel computations that are called as parallel algorithms. So it is very important to ascertain the capability of computational device before designing or choosing the algorithm. Next is choosing exact or appropriate problem solving technique. For certain problems we will get the exact result, but we cannot calculate the square root of 2 exactly. So we must choose between an algorithm which gives exact result and an algorithm that gives approximate result. In approximate algorithms, we cannot get the exact result. For example, to obtain square roots for some numbers, solving nonlinear equations, etc., we have to choose among exact or appropriate algorithms based on the problem. Next is selection of appropriate data structures. Once we have selected the type of algorithm, that is sequential or parallel and exact or approximate, then we have to choose the proper data structures to represent the various data types for easy manipulation and to achieve the result. By combination of algorithm and data structures, we can easily obtain a program. Next we have the design of algorithm. After the problem is clearly stated and the type of algorithm and data structures are selected, the solution to solve the problem should be specified. Each statement specified must perform a well-defined task or operation, and finally required result should be obtained. One algorithm may be efficient and faster and difficult to understand, whereas another algorithm may be slow and easily readable. Run, run it on variety of test inputs and see whether the desired result is obtained. For a variety of input data, if the desired output is obtained, we can say that the algorithm is correct. An algorithm can be expressed using natural language, pseudocode, and flowchart. Natural language in the form of C, C++, anything you can use, higher level language. Next, you have the proof for algorithm's correctness. After specifying the algorithm for a specific problem, we have to prove its correctness. It is our responsibility to prove that the algorithm produces the required output for every legitimate input in a finite amount of time. Proof of mathematical induction is most appropriate for proving the correctness of the algorithm. Next, we have the analysis of the algorithm. Here, the estimate of time and space for a given problem. Next is the analysis of algorithm. This is also one of the important steps. Here, the estimate of time and space for a given problem should be obtained. Once we have these estimations, select an algorithm which is more efficient in terms of time and space. Time efficiency indicates how fast the algorithm runs, and space efficiency indicates how much extra memory is required for the algorithm. Analysis also helps to find the bottlenecks in a given problem. For example, which portion of the program consumes more time? By knowing this, one can redesign the algorithm to solve the same problem much efficiently and easily. The weaker algorithm can be improved. It is very important to write the program so as to maintain the simplicity. The simple algorithms are easier to understand, debug, and easy to program. Another characteristics feature of an algorithm is the generality. It is required to write general programs always. Next, we have the implementation. The program design should be implemented using programming languages such as C or C++ or any other suitable language. Usage of different languages for solving a problem results in different memory requirements and affects the speed of the program. The syntax may vary from language to language. The selection of the programming language is also important. The language selected should support the features mentioned in the design phase. Next, we have the program testing. After implementing the program in a specific language, next is to execute. After executing the program, the desired output should be obtained. Testing is nothing but the verification of the program for its correctness. That is, whether the output of the program is correct or not. Using different input values, one can check whether the desired output is obtained or not. Any logical errors can be identified by program testing. Usually, debugging is part of testing, and many debugging tools exist by which one can test the program for its correctness. Last is the documentation. The documentation should exist from understanding the problem till it is tested and So these are the various steps which are involved in the design and the analysis of the program of the algorithm.